Earth Systems 3209, Unit 3, Earth's Materials. Reference for this unit can be found in the textbook in Chapters 2, 3, 6, 7, Appendix A and Appendix B of the Curriculum Guide. Unit 3, Topic 5.4. This topic will discuss metamorphic environments, in particular the contact metamorphic environment. We will focus on describing the environment's location associated with contact metamorphism, and we'll also focus on illustrating how contact metamorphism can be used to help identify an igneous intrusion and distinguish it from a buried lava flow. When we look at metamorphism, metamorphism literally means to change form. These changes take thousands, if not millions of years to complete. During this period of change, minerals within the rocks flow in solid state and can change on the atomic scale. Bringing about these changes due to metamorphism are the agents of metamorphism. And your three agents of metamorphism include heat, pressure, and chemically active fluids. Metamorphism most often occurs during one of two geologic events. The first geologic event where metamorphism can occur and where metamorphic rocks are often found is during mountain building. When mountains build up, they are exposed to extreme pressures by the collision of tectonic plates and also exposed to extreme heat by magmas intruding within the mountains. And because of this extreme heat and extreme pressure, we see regional metamorphism in mountain building. Associated with igneous intrusions, we see extreme heats. When magma or lava are exposed to rocks, they end up changing the rock because of the high heat. This changing of rock due to high heat is called contact metamorphism, and this will be the focus of this presentation. References in your text can be found on pages 198 to 201. When we look at contact metamorphism, this type of metamorphism occurs when rocks come in contact with magma or lava, therefore being exposed to extreme heat. The changes are caused primarily by high heat temperatures of the molten rock, which in effect bake the surrounding rock. Some examples of contact metamorphism includes when rock such as limestone changes to marble, and also we can see surrounding igneous intrusions we can find hornfels. In the diagram below, we see contact metamorphism is indicated by the X's in the diagram. And on most diagrams that you will see, the contact metamorphism will be distinguished by the X's in the diagram. Or there may be a legend present that may give you a different symbol outlining what the contact metamorphism would look like in the diagram. Where does contact metamorphism occur? Contact metamorphism is generally associated and found with lava flows. When lava flows onto the surface, contact metamorphism could be found beneath the lava flow, where the hot lava comes in contact with rock and results in the burning of the rock that it touches. A second place where we find contact metamorphism is adjacent to magma intrusions. When magma intrudes or moves up through rocks, such as along cracks or other fractures, the magma will burn the rock it comes in contact with. Therefore, contact metamorphism is found adjacent to magma intrusions. And a third place where we find contact metamorphism is bordering dikes and sills. In the diagram below, we see that a dike is an igneous intrusion which cuts across rock layers. And on the outer edges of the igneous intrusion, we see contact metamorphism. A sill, on the other hand, is an igneous intrusion which cuts in between rock layers, so therefore is parallel to rock layers. Therefore, the contact metamorphism again is on the surrounding edges. In the diagram here, we don't see the X's that represent contact metamorphism, but we could indicate all the way up through, and we see an area that is slightly shaded, which do indicate contact metamorphism. But we would see contact metamorphism in diagrams that we see in this course, generally represented by X's. And these X's are seen bordering the actual dikes, which is an igneous intrusion that cuts across rock layers, and it can also be found bordering sills, which are igneous intrusions that intrude in between rock layers. So we would see resulting contact metamorphism, which is a bait area around sills and around dikes. When we look at contact metamorphism can distinguish between a buried lava flow and an igneous intrusion. When we look at a buried lava flow, the lava itself makes its way to the surface, where it flows onto the surface. The lava then solidifies, forming a solid layer. At a later time, the lava will be buried by other rock layers, other sediment layers. Therefore, there is no contact metamorphism located above a lava flow. In comparison, a magma intrusion would have contact metamorphism located above and below the magma intrusion. This is due to the fact that when magma intrudes up through rock layers, and it could squeeze in between rock layers, or it may not make it to the surface, it burns all the rock that it comes in contact with. That is, rock above and below the actual intrusion. So if we look at the diagram below, we see two areas, one represented by the letter B, and a second represented by the letter R. One of these igneous rock units would represent an intrusion, and the other would represent a buried lava flow. If we look at the lower rock unit, denoted by R, we see that we have contact metamorphism represented by X's below the rock unit. But we do not see any X's above the rock unit. This absence of X's, which represent contact metamorphism above the rock unit, would suggest that rock unit R is a buried lava flow. The actual layer of sandstone, represented by the dots, would be deposited on the lava flow after the lava flow had formed. If we look at rock unit B, we see that we have X's both above the rock unit in the lower part of the limestone, and we also have X's below the rock unit in the upper part of the sandstone. These X's again represent contact metamorphism, and because they're located above and below rock unit B would represent an igneous intrusion. This is a rock unit that formed when magma moved up through rock layers, and it actually intruded in between the resulting sandstone, burning it on the bottom, and the limestone, which it burned it above the igneous intrusion. So in conclusion, B represents a magma intrusion, and R represents a buried lava flow. And an igneous intrusion would contain contact metamorphism both above and below the actual igneous rock unit, whereas a buried lava flow would only have contact metamorphism, represented by the X's in the diagram, below the actual lava flow, and no contact metamorphism, or X's, above the igneous rock unit. This would distinguish it as a buried lava flow. Also, when we look at contact metamorphism, we also see chilled margins within the actual igneous rock unit. When lava pours over rock or magma intrudes rock it starts to cool and crystallize. The contact metamorphism occurs where the hot lava or magma touches the old, previously existing rock. So in the diagram below, we see that the contact metamorphism is represented by the color yellow. We do not see any contact metamorphism above the basalt, which is represented by pink. Therefore, this diagram would represent a buried lava flow. When we look at the magma intruding through rock units, the magma starts to cool slowly, so crystals grow to be large. However, the magma cools faster on the outsides since the cold, previously existing rock unit causes it to cool a little faster. Therefore, you get larger crystals toward the center and smaller crystals on the outside edges. And this gives a chilled effect. And this is what we refer to as chilled margins. So if we look at the diagram to the right, we see that we have an igneous intrusion represented by the shaded area in the center, moving up through surrounding rock, represented by the gray areas. As the igneous intrusion moves up through the surrounding rock, it loses heat to the surrounding rock, and therefore starts to cool rather quickly. This quicker cooling would cause the margins on both sides of the igneous intrusion to have fine grain or glassy texture, and these are called chill margins. Let's look at some examples from past public exams. First question reads, which is the main factor causing contact metamorphism? So if we look at the agents of contact metamorphism, we see that chemical fluids would be present, pressure would be one of the main agents of metamorphism, and heat. But because we're dealing with contact metamorphism, heat would be the most important factor that would cause contact metamorphism. So our answer to the first question would be B, heat. Second question states, what feature is represented by the X's in the diagram below? So if we look at the diagram to the right, we see that we have an area of once molten rock. We see X's located below the once molten rock, and we see X's represented above the once molten rock. So in review, this diagram would represent an igneous intrusion and not a buried lava flow, because we have contact metamorphism on the top. So therefore, the answer to this question, the X's, would represent contact metamorphism. And the contact metamorphism both below and above the igneous rock unit would suggest that this would be an igneous intrusion. Example number 2. What will the rock surrounding the magma chamber in zone Y be exposed to? So if we look at the diagram to the right, we see we have a magma chamber surrounded by a purple area, and this purple area is denoted as zone Y. So surrounding the magma chamber, we have rocks that are exposed to extreme heat. Therefore, if they're exposed to extreme heat, they will be characterized by contact metamorphism. The rocks will be baked and therefore change, resulting in a metamorphic rock forming. So the answer to this question will be A, contact metamorphism. Your turn. Take time now to complete the following question. The solution will follow on the following slides. The question reads, how can contact metamorphism distinguish an igneous intrusion from a buried lava flow? So if we look at the question carefully, it asks us to refer to contact metamorphism and how can it distinguish an intrusion from a lava flow. If we look at the answer reads that contact metamorphism would reveal if an igneous rock unit was an intrusion or lava flow by looking at where the contact metamorphism is located. And this would be the key. The key would be looking for where the contact metamorphism is located. An intrusion would have contact metamorphism both above and below the igneous rock unit, whereas lava flows only show contact metamorphism below the igneous rock unit. So these are the two key points that you would use to distinguish between an igneous intrusion and a lava flow. Igneous intrusions show contact metamorphism both above and below the igneous rock unit, whereas a lava flow would only have contact metamorphism located below. There would be no contact metamorphism above the igneous rock unit. In summary, contact metamorphism forms in areas of high heat. So high heat is the agent of metamorphism that is important when looking at contact metamorphism. Also, contact metamorphism is associated with lava flows, intrusions, and also dikes and sills. And we can use contact metamorphism to identify between an igneous intrusion and a buried lava flow. So in conclusion, contact metamorphism is represented by X's located in diagrams, and this contact metamorphism can be found above or below areas where molten rock comes in contact with the surrounding rock.